na ano, related to isothermal and isentropic processes. Okay. So here, for example, number 3 pala. This is an example of isothermal process. So for number 3, there are 2.25 kilogram per minute of steam undergoing an isothermal process from 27.5 bar, 316 Celsius to 6.8 bar. Okay. So determine change in entropy, the heat or DQ or heat transferred, the work non-flow and work steady flow if the change in kinetic energy is 42 kilojoule per minute. Okay. So let's draw muna our PV and PS diagram. So datan ko na lang. So this is PV. And this is our TS. So from this one pala, our problem, we can determine both properties of the steam. So sa first kasi natin, shell properties, and so we have steam undergoing process, 27.5 bar and 316 Celsius. So anong pressure yung 27.5 bar? So we have pressure conversion, balikan lang natin, of 1 atm. This is equivalent to 101.325 kPa, 0.013 bar. So it is, we also have a conversion factor generalized as 1 bar is equivalent to 100 kPa. Yan. Hundred kPa. So for this problem, ay nitong 27.5 bar, yung 27.5 bar magiging 2,750 kPa pala. Or simply 2.75 MPa. At the same time, itong 6.8 bar natin magiging 680 PPA or just simply 0.68 MPa. Okay. So in this problem, malidetermine natin superheated kaagad yung initial and final properties natin. So from our initial property kasi we have 27 or 2.75 MPa as our initial pressure. And then if we go to your steam tables, kahit umpisa nyo muna sa saturation pressures, ito kasi sa superheated steam na part ng steam table nyo, yung katabi niyang pressure ito, this is our pressures. Yung katabi niya is our saturated temperatures. Ito, saturated temperatures yung mga yan. So since the saturated vapor temperature or saturated temperature ng 2.75 MPa is 229.12 lang. And in our initial properties, ang temperature natin is 316 degrees Celsius. So nag-exceed siya ng ating nag-exceed siya sa saturated temperature supposedly ng ating pressure. Napakalayo. So this is obviously a superheated vapor or superheated steam. Kagaya din ng ating final properties naman. Yan. So at point 0.68, yan, 0.68 MPa. Ang saturated temperature niya is 163.81 degrees Celsius lang. Yan. So diyan siya nag-i-start mag-expand as a steam. Yan. Since 316 yung given nating temperature, take note this is isothermal kasi, so temperature 1 is equivalent to temperature 2. So napakalayo din ng difference ng saturated temperature sa given nating temperature. So we will treat this also as superheated steam. Okay. So going back, isend ko na lang tong crop steam properties or steam table, the GC. So our PV, yan. Let's draw first our PV before determining our properties per points. Ayan. So they are both superheated. So technically, this is our initial point for our PV. And then nag-superheat lang siya. So hindi siya magkukross ng line or hindi siya mag-intersect ng line ng ating saturated vapor. Take note, saturated vapor yung linyang yan. So parang nagganyan lang siya. And a curved line. So this is our point 1. And nag-expand yan or nag-expand yan under isothermal sa point 2. So bumaba kasing pressure niya. So this is pressure 1 as 2.75 MPa, and then this is pressure 2. Bumaba yung pressure natin at 0.68 MPa. So for our PS diagram, simply this is 0.1 and then 0.2. Parang ganun lang. Bakit? Andyan? Kasi both properties o both points kasi are superheated steam. So nasa right side yan ng ating saturated vapor. Okay. So at point 1, kunin natin yung properties niya at point 1. At 1. Ano yung mga kinukuha natin? Change in entropy, heat, work ng flow, and work steady. Pangit yung mouse ko. So initial properties, point 1 natin. Ito yan. So una, entropy muna since we're looking for entropy. Okay. So 2.75 MPa, ito yan. And then 316 degrees Celsius. So ito yung ating temperature na column or row. Pupunta tayo dito sa gitna ng 310 and 320 degrees Celsius. So i-trace lang natin yan to the left, going left para ma-align with the 2.75 superheated properties. And ito yung focus natin sa 2.75, and then lipat na lang natin itong 310 and 320 sa other side para mas madaling i-treat or basahin. And dito yung 310 and then this is 320 sa kabila. Sorry. Basta 310 and 320. Dito yung isa. So interpolation lang. Ituro ko naman sa inyo last time yung interpolation. So getting the entropy. So obviously nasa gitna or dito yung properties natin between 310 and 320 degrees Celsius. For entropy, we can get the entropy as then yun. Try this. So, i-tweet nyo yan dito sa itong one. Higher natin is 6.6733. 6.67 minus our lower or nasa 310 natin entropy is 6.6321. Okay. 6.6321 over our higher natin that is 6.6733. I think this is the other interpolation method. Diba to dun sa naturo ko last meeting. And then, this is minus our entropy na. Correct na yan. Minus our entropy 1 or S1. Yan na yung entropy 1 natin. Pakisolve nga. Pakilabas mga calculators and try to solve. Excuse. Anybody who got the answer already for our S1? So, repeat the process lang natin hanggang makuha natin yung entrophies, rather, our internal energy and enthalpy. So, kahit huwag mo natin kunin dito yung ating specific volume since hindi natin siya needed dun sa mga depth, kailangan natin i-determine na parameters. Answer? May nag-solve ba? Okay, solve ang ating entropy 1. Put yung shortcut yun. Parang ganyan, 10 all over 4 yan, di ba? It's equivalent to the input nyo. So, parang pwede yung i-times yung 4 lang sa numerator nito. And times din sa baba. Kaya pa i-shift solve nyo na lang. Wala. Okay, so if we're gonna solve, the answer here is 6.65682 kilojoule per kilogram Kelvin. Okay, so our entropy 1. For our next, for our enthalpy 1 naman. Okay, the next page na lang. Simple interpolate natin dito. Copy ko na lang. So dito yan, sa gitna ng 310 and 320, ang gitna natin. So, interpolate natin. So, higher limit natin is 3050.1 minus 3025.9 all over higher limit, that is 3050.1 minus x, or our enthalpy 19, correct na natin yan, equivalent to 320 minus 310. Or simply, this na yan, numerator ng other side, all over 320 minus 316. Bakit 316? Kasi yan yung temperatures natin, or temperature not given in that property, or in our initial property na temperature natin. So, 316. Interpolate nyo lang. Pwede shift solve yan. Pwede yung erekta sa calc yung ganyan. Shift solve. Pwede nyo rin manu-manuhin algebra. Interchangeable yung positions natin. Pwedeng nasa left hand side yan. Pwede rin right hand side. Same lang din lalabas na enthalpy. Okay. May may so 3040.42. Okay. Kilojoule per kilogram. Okay. Our U1 naman, or internal energy 1. Same process lang din. So, erekta nyo na, calculate nyo. So, that would be, yan, 2793.4 minus 2774.8 all over, yan, yung higher limit natin, that is 2793.4 minus U1 or X sa inyong calculator. So, shift solve, equivalent to technically, para mabilis kayo mag-input, 10 over 4 lang yan. Erekta nyo ng minus before nyo ilagay sa calculator para mas mabilis. This is 10 over 4 lang. Answer? Mr. Suliban? See, sulat ko na lang. So this is 2793. And 4 minus 2774.8 all over 2793.4. This is our higher limit minus U1 na yan or sa calculator nyo, alpha x or yung x nyo dyan para ma-shift solve. Equivalent to, so erekta na natin minus yan. So 320 minus 10, that is 10. Over 320 minus 316, that is 4. So if you shift solve nyo yan, you can get U1 agad. Yun lang.
Two 2785.96, sir.
Okay, ulit, mister. 2785.96.
85.96. Yes, sir.
Kilojoule per kilogram. Thank you. Mr. Carpio.
Yes, sir.
So, meron na tayong initial properties. Let's get our final properties naman or at point 2. Copy na natin to. Pwedeng dito na lang. So, next pages na. So, at point 2, it is still superheated. So, dito, ang gagamitin pa rin natin steam table is under the superheated part or yung superheated vapor natin. So, under 680 or 680 kPa or 0.68 MPa, ito yung properties niya. Under 310 and 320 tayo. So, dito yung 316 natin. Malakihin ko pa. Okay. So, for our entropy, pwede nating erekta na yan. Okay lang ba erekta na natin? Kahit huwag na yung itong interpolation part. Yeah. Lagay ko na lang. So that is under between 310 and 320 we have entropies. Okay, higher limit natin si 320. So that is 7.3836. So 7.3836 minus 7.3481. Okay. All over. Yan. Baba lang ulit natin yung higher limit. That is 7.3836 minus x or that is S1. Kumari, ito yung calculator x yan. And then sa kabila, that is simply 10 over 4. Or ito lang din yan. 320. Ay ko dito. Same lang yan. Sa 320 minus 310 all over 320 minus 360.
Sir, excuse me po. Yan na po ba yung sa 0.68 MPa?
Ay, so S2 pala. Yes. Yes, this is the point 2 or final properties. So, S2 yan.
Sige sir, thank you po. Nalito lang kasi ako sa S1 yung
Oo nga. Ano din nilagay ko. Okay. So, ilan yung S2 natin?
7.3694.
Okay. Kilojoule per kilogram Kelvin. So, ganito lang. Kailangan lang maging mabilis kayo sa pag-determine ng properties, pagbasa ng steam table, and pag-interpolate. So, ito lang din kasing kalaban nyo if may quiz ganyan. Yung pag-determine ng properties. Simply kasi meron tayong steam table para i-base yung mga properties natin. Hindi natin kailangan i-solve yung other properties. So once na-determine yung properties, madali nang i-solve yung mga pinapadetermine or hinahanap in case sa termo to, sa mga pagdating yan ng runtime cycle ganyan. So yun ang kalaban nyo mismo yung pagbasa ng table and pag-interpolate ng properties. Okay. So H2 and U2 na lang kulang. Ito ko nalagay. So for H2, okay. So between or 316, this is in between 310 and 320. High limit is at 320. We have 3101.4 minus 3080.5 all over. Yung mga nakakasunod, pwede nyo nang i-solve ka agad or i-shift solve ka agad para mabilis tayo. Minus X or H2 ko na lang. It's equivalent to 10 over 4. And for internal energy naman, we have 28. 31.6. Minus 2815. This is U2 or internal energy 2. And energy 2 equivalent to 10 over 4 lang din yan. Resolve na lang si H2 and U2 natin.
Sir, yung H2, 3093.04.
Okay. U2 ay. U2. So while others are solving for U2,
Sir, yung U2 po, ano? 2825.2.
Okay, thank you. 2825.2. Sige, so sobrang natin yung kailangan natin. For letter A, that is change in entropy yata. Change in entropy, heat, work done flow, and work steady flow. Okay. Change in entropy, that is simply S1 minus S2. Since given na yung ano, or nasolve natin, nakuha na natin yung S1 and S2. S2 over S. Mas malaki si S2. S2 minus S1.
Sir, pag mas malaki yung S2, pwedeng magbaliktaran.
Kamali lang ako. So that is still S2 minus S1. H2 minus H1 and so on. Right, okay. S2 natin. So we have 7.3694. Minus our S1. It is 6.6568. So both are in kilojoule per kilogram Kelvin. Therefore, delta S would be equivalent to so we can also multiply here our mass flow rate. Meron tayong mass flow rate dito that is 2.25 kilogram per minute. Okay, so cancel lang si kilogram, mapapalitan ng minute. So in some cases kasi pwedeng, and since yun naman tinatanong dito, usually convert muna natin si kilogram per minute into kilogram per second. Para for getting our work and energy, parang rekta na natin magiging, diba, kilojoule per kilogram multiplied by kilogram per second. Pag naka-kilogram per second na yan, makakasa lang sa kilogram, magiging kilojoule per second na, or simply kilowatt, yung kilojoule per second. Para minsan ng conversion na we can convert to into kilogram per second, and then yun yung gagamitin nating mass flow rate or product. Anyway, so kahit ito lang muna, kilogram per minute. Ilan?
1.5912.
1.15. Okay, ulit, Mr.
1.5912, sir. 5912.
So this is kilojoule per minute Kelvin. And then letter B, yung ating heat transfer. So if ma-recall nyo yung formulas na binigay ko, last year pa yun, or yung ating, before tayo maging formulas for process, we have heat transferred for isothermal as T delta S. Is na tayong delta S dyan. So, i-convert na lang natin yung T natin. Given natin T, our temperature is 316. Yan. So, kailangan natin yung gawing Kelvin by just simply adding 273. Yan. So, this is Kelvin multiplied by our delta S na 1.5912 kilojoule per minute Kelvin.
Sir, excuse me po. Wait lang po.
Okay.
Sir, di ba ano po? Doon po ba sa delta S na 1.5912, na-multiply na po ba doon yung 2.25 o hindi pa?
I don't know. Sige.
Kasi po, kilogram per second po yung sinasabi nyo kanina, di ba?
Kahit minute lang. Okay na yung minute lang.
Ay, sige po.
Pero ano bang ano ba itong answer na to? Naka-second? Paki-confirm na yung natin, delta S natin. Mukhang tama naman. I-minute pa rin natin. Okay, so tuloy lang natin. Sa Q natin, makakasa lang yung Kelvin natin. Excuse. So 589 multiplied by 1.5912 lang. So that is 937. 0.2168 kilojoule per minute. Okay. So pag kilowatts yan, magiging 15.62 kilowatts. Okay, that's fine. Hindi naman sinabi po anong final units. So pwede yan. And then for letter C, hinahanap for letter C is our work done flow. So work done flow natin, our general formula for work done flow is simply delta U plus or minus U minus delta U from our general formula na heat is equivalent to delta U plus work done flow. Yeah. Transpose na natin si delta U. Okay. So, nasolve natin yung heat natin. That is 937. Point 2168. So, delta yun na lang. Kulang natin. And, hindi naman na mahirap yan since na-solve na natin or nahanap na natin yung properties natin for U1 and U2. Ito natin. Okay. For delta U, U2 minus U1. 2825. Minus 2785.96. So ilan na yun? So that is 39.24 kilojoule per kilogram. That is our change in internal energy. So we can still, or we can multiply this with our mass para maging similar unit siya ng ating heat na kilojoule per minute. That is 2.25 kilogram per minute. Okay, so cancel lang sa kilogram. And we have a delta U of that is 88.29. Kilojoule per minute. Yan. So, lagyan lang natin dito 88.29. Yan. So, both units or both are in kilojoule per minute. So, therefore, our work done flow for this problem is
848.9268.
this is kilojoule per minute. Okay. And then lastly, for our this is work steady flow naman. Then given ang ating formula for work steady flow as that is heat minus potential energy, or change in potential energy minus the change in kinetic energy minus the change in enthalpy. So given tayo ng ating KE from our problem and then walang PE. So magiging zero lang yan. Walang given na height or elevation and then walang given na PE mismo. So it is safe to assume na zero C potential energy. Okay. So solve lang natin si change in internal energy. So this is simply H2 minus H1. Multiplied by the mass. We have our H2 as 3093.04. And as our initial enthalpy as 3040.42. Multiplied by 2.25. Okay. So, ganito lang din yung unit analysis niya. Therefore, our delta H is
Negative 3747.
negative ba?
Yes, sir.
Ulit na lang. So, that is 3093.04.
118.395.
Okay. 395.
Yes, sir.
This is kilojoule per minute. O kilojoule, tama, kilojoule per minute. Okay, so pwede natin i-solve ang ating work study flow. So we have previously nasolve natin yung heat natin. So that's 937.2168. Bakit kasi na-mouse ko eh. And also our kinetic energy, change in kinetic energy given yan sa ating problem, that is 42 kilojoule per minute. Minus our change in enthalpy natin. So that is 118.395. Ayusin ko na to. Ilabas ko na lang. Kilojoule per minute. Okay, so what is our final answer?
776.8218.
0.8218. Okay. So, ganoon lang on kung paano yung isothermal natin. So, yun lang din naman. Technically, same temperature. Around 0.1 and 0.2. Kaya ito rin pala yung ating TS is straight line since hindi nagbago yung temperature natin from 1 to 2. Okay. So, any questions? Kung paano natin nakuha yung delta S, the heat transferred, and then work done, steady flow, and work steady flow. Or if nalilito kayo sa interpolation and table, pwede yung sabihin. Ulitin natin. Any questions so far, class? So, if wala, let's proceed sa example natin for our isentropic process. Okay, so a steam turbine receives 0.52 MPa of steam at 300 degrees Celsius. Okay, so our point 1, obviously that is superheated na din since 300 degrees Celsius na yung kanya. As then, so then expand in an irreversible adiabatic process to a pressure of 0.012 MPa. Okay, so if the exhaust steam is dry and saturated, calculate the work of an irreversible process and the efficiency of the process. Okay. So for this naman, let's just redraw the PV and TS. Ulitin natin. So this is adiabatic or isentropic process. So entropy is constant. Okay. So technically kasi, if for this example, parang ano siya, TS lang yung mag-affect dito since this is our point 1. Ito yung TS na lang. So this is our pressure 1. And nag-expand daw yan, universal adiabatic. So technically, dapat magpo-fall siya dito. Since we're talking here with isentropic. So straight line lang yan, syempre, di ba? Yung S. Or yung, since our S is the x-axis and then we're dealing with isentropic, theoretically, dapat straight line lang yan. Pero sabi dito sa problem is, if the exhaust steam is dry and saturated, so parang lumiko daw yan, naging either nag-stop siya dito or at this point kasi given din tayo ng pressure natin at ito, 0.1, 0.012 MPa. Okay. So, if the exhaust steam is dry saturated, parang gumanon yan. Bumilid dito para maging saturated. Para matamaan niya pa yung line of saturation natin. Ito lang pala. Okay. So, ayun, doon natin makukuha yung efficiency of the process. Anyway, let's solve or let's determine the properties first. So for initial properties, wait lang, nag-load. Okay. This is at point 2. And given temperature of 300. Okay, so once again, i-repeat ko lang. At 0.52 MPa, ang saturated temperature niya is 153.34. And since our given property claims na 300 degrees Celsius yung steam natin, so nag-exceed siya sa saturated temperature natin. Therefore, this is superheated. Okay, so for superheated, hindi natin kailangang interpolate kasi given kasi nakasaktong 300 degrees Celsius na yan. Okay. So, under 300, ito yan. I-trace lang natin yan dito sa row ng ating 0.52 MPa. Okay. So, ito na lahat yung properties natin. Lista ko na lang. Let's just list them down. So, for our S1, which is technically dapat S2 din natin. This is 7.4411. Kilojoule per kilogram Kelvin. Each one natin, we have 3063.7. And then at our internal energy, we have 2 02.6. Okay, yan lang. Ano tayo dyan? Okay, so theoretically, dapat, if ideal isentropic tayo, this should be equivalent to our S2 natin. But since, balik natin yung people. But since, sabi dito sa problem natin is, if the exhaust steam is stress saturated, so meron tayong ginawang method or ginawang process para maging saturated yan. But if it is not given as saturated, S2 lang din natin yan. Since asymptotic tayo, straight line lang yan. So, to clarify lang, under, for steam, for superheated steam, superheated vapor, nakalagay na rin dyan yung saturated vapor natin na properties. Under sat. And so, temperature is saturated. So, yung properties na ito, this is saturated vapor properties na rin yan under 153.34 degrees Celsius. Okay. So, ito na yung kanya, properties niyan. So, sabi dito, if it is saturated vapor, nung nag-exit siya, or final process niya, meron tayong entropy niyan as 6.8081 kilojoule per kilogram Kelvin. And our enthalpy is 750.5. Pwede natin i-compare yan doon sa saturated pressure natin pan. Para just to prove, same lang din yun. Itong properties na to. Okay. So this is in saturation pressures properties. So under 0.52, ito yan. Ito na part. Okay. So our HG natin is 2750.5. Ayan, same yan. Then our SG, ito yung SG natin, under 0.52 is 6.8081. Same lang din sa S2 or SG na nakalagay dito. Properties na ito. Okay. Ayan, what else? Hindi natin kailangan yung kahit mo na yung U or either energy. Okay. So, mabilis na ito. Okay, so, hanapin lang natin yung hindi ko na-picturean yung properties at point. Ito. 0.012 MPa. So, dito yan. Wait nyo. for our final properties, so, labo. So this is saturation pressures. This is not superheated. Ano tayo dun sa ito, 0.012 MPa. So andito yan. Medyo malabo nga lang. So kukunin natin yung properties niyan. So we have Hg at this point, or H2 natin, equivalent to Hg at the pressure 2, or 0.012 MPa. So our Hg is 2591.1. Kilojoule per kilogram. Also, we must get our entropy at this point. So that is 6.056.3. Di ba, this is wrong pala yung ating kinuha dito. Pero magagamit pa rin naman natin yun. So that is S2 natin. Is it? Ito yun, no? 6 point, or 8 pala, 8.086.3. Okay. So for letter A, ang hinahanap lang naman dyan is simply work of an irreversible process. Balik ko lang to. So that is just simply, technically this is H2 prime. Since original H2 natin kasi, or this is 0.1, so this is 0.2. Ideally, this is 0.2. Yung point dito, nung naging saturated yan, that is parang 2 prime, 0.2 prime. So for letter A, ang work steady flow natin, or the work of an irreversible process, is simply our H1 minus our H2 prime, or yung saturated na at 0.1 or 0.012 MPa. So for letter A, it's simply 3063.7 minus our H2 prime, that is 2591.1. Both are in kilojoule per kilogram. Walang binigay na mass flow rate or mass, kaya hindi natin kailangan i-cancel yung kilogram or multiply into a mass. So work steady flow or work irreversible process natin is
472.6.
472.6 kilojoule per kilogram. Okay. So for letter B, kinukuha kasi dyan is efficiency of the process. So since this is process lang, hindi pa tayo cycles, ang tinutukoy dyan is yung efficiency or E. Sige, N na lang. That is work steady flow prime all over work steady. Yan. So technically, ito na yung numerator natin. Pero for the denominator, yung work steady na hindi prime, i-solve muna natin yung since wala nang time, solve muna natin yung mix wet mixture natin or mix vapor natin dito. Yung wet mixture vapor natin dito at point 2 when this is an isentropic. If na-solve na natin yung H2 natin na wet mixture, ayan, we will solve for our work of an adiabatic reversible process na S lang or isentropic. And then if we solve our work steady flow only na hindi prime, divide lang natin siya sa steady flow. Okay, so I will send na lang the screenshot if matagal namin sa block 1 yung dito sa part na to. So same example lang din naman ibibigay ko sa kanila. Pero for letter A, this is the final answer. And then I will send na lang a screenshot of the letter B if matagal namin sa amin. So before I dismiss you guys, let me just check the attendance. Sir Asho.